What is machine learning? Machine learning is really just math. It's input-output functions. Maybe it's something that you have already done and didn't even realize it. Welcome to Democratizing AI. The mission of this channel is to make AI more usable. Because guess what? We're product people. We want our products to be useful, and we know that if we can do this, then we will have much bigger impact. So if you are excited about applying this technology, AI, in a way that's more impactful, more useful, to drive business impact, subscribe to the channel, and let's dive in. Machine learning. When I was in my PhD program, this is something that I spent a lot of time learning about. And my research supervisor explained to me one day, he said, "Look, Jacob, we have lots of different terms here in the academic community, and machine learning, AI, it's really just the same statistics that has been around for decades. We just packaged it up as something new and cool because the government organizations that approve our grants, if we just called it statistics again, they would think that it's old and boring and there's nothing new to research, and so we gave it a new name. And that new name says, ooh, this is cool, this is new, this is innovative. And we can get a lot more grants by repackaging and representing the same old stuff as something new." I was pretty surprised. But guess what? In the software space, we do the same thing. It's called positioning. It's called branding. If you're in the B2B space, you've probably heard of Gartner and Forrester. They have their quadrants and the Forrester wave, and everyone wants to be up and to the right. And let me tell you, if you want to have a good score with Gartner and Forrester, you better be using the right buzzwords, and you better be presenting and packaging things in the right way so that you have a good evaluation with them. So it's the same game, it's just human psychology. Now, back to machine learning functions. I'm going to give you a real simple example, and then perhaps you'll realize that you've already done machine learning previously in your life. You have a data set with 2 data points for each instance, 2 columns. You can put this in Excel. You have students, and for each student you have a number of how long they spent studying for a test, and you have a score from 0 to 100 on how they performed on that final test. As you can imagine, there probably is some sort of pattern that lives in this data set. Most likely, the students that spent 0 hours studying for the test are going to have a lower score on average than the students that spent 10, 15, 20 hours studying for the test. You can plot this data set on an x-axis and a y-axis. And you'll most likely see some sort of trend. Of course, there's going to be some anomalies, there's going to be some noise. But if you use statistics to average out, you can plot a line, a linear regression model, or linear regression, and it will be sort of in the middle of that cloud of data points. You can use that line that's fitted to the center of that data, and this is a machine learning term. When you train an algorithm, you fit the model to the data. And the more data that you feed the model, the more accurate the model becomes. You can use this model to predict the future. You can predict the future because human beings notice the same patterns that these equations do. You now have this line, and of course you'll know that if you only have 2 data points, a student who was kind of a fluke and studied a lot but still got a low score, and another student who only studied for 2 hours and got a high score, that's going to be a very inaccurate model. That's why people say that data is the fuel of machine learning. It is the intelligence. Without data, there is no machine learning. And that's why the more data you aggregate, the more powerful and more predictive your algorithms become. You'll look at lots of acquisitions that are happening in tech right now. Lots of these acquisitions are motivated by being able to acquire those very valuable data sets that can then be used for very useful machine learning applications. So now let's say you have more than 2 data points. You've been a teacher for quite a few years and you've got a model that's fitted pretty well. Now if you have a student that has studied for 5 hours, with some margin of error, you just plot it right there on that line and you can make a prediction of most likely in what range that student is going to perform. That's all stats. Now the complexity here is, and this is where machine statistics evolves and turns into machine learning, is when you have lots of data points. When you have 3 data points, you can kind of create a 3D model, x-axis, y-axis, z-axis, and there's some, you can look up some pictures. There's 3D models that find those patterns on a 3D plane. 4 data points, ooh, how do you visualize that? And oh, what if you do like male, female, or like other attributes like member of the loyalty program, not a member of the loyalty program. That's categorical data. So how do you incorporate that into this model that's finding patterns? That's really all machine learning is. Machine learning is dealing with the complexities of statistics at a larger scale. The most cutting edge innovations in machine learning are in the latest years have been using neural networks. Neural networks are amazing because they're not only finding patterns between the data points in your data set, but they have the power to find hidden features or hidden patterns. That's why the more layers your neural network has, and I'm probably getting a little bit too technical here, but perhaps we'll dive more into this in other future videos. But the more layers you have in a neural network, the more power your algorithm has to say, what about male and the loyalty status combined together? And what about their height and their income? What if there's not really a pattern between height and income, but what if height plus income minus their gender has some sort of pattern? That's neural networks. Neural networks are finding patterns that you didn't even think, that you did not even conceive were there. Using test score prediction, you can already imagine that there likely is a pattern. But neural networks are incredible because they find patterns that you did not, that are crisscrossed back and forth within your data. And that's the only way that we were able to do computer vision. Because if you look at pixel 1 and pixel 2 and pixel 3 and pixel 4, if the pixels are just up by 1 row, then boom, your computer vision algorithm fails because the pixel that has a pattern and an RGB value right here on your computer vision predictor, now that the cat face is shifted slightly to the right, oh, your computer vision, and this is what was happening. This is literally how machine learning computer vision worked for like the 80s and 90s, is they're like plotting the pixels and like those were the data points in your data set. Pixel 1, pixel 2, pixel 3, pixel 3. But if you find patterns in between the pixels, then it can say, hey, even if the pixels are over here, but you find the pattern of like this shape of a cat's nose and this type of an ear, even if it's over there, like if you find those types of patterns, that's how computer vision uses. And it's just statistics. Computer vision is statistics with a data set that is so monstrously huge that you could never use a linear regression. So there you go. You have the simple explanation of what machine learning is. And we're going to dive more into, there's more types of machine learning algorithms and more types of models that can be used for different types of use cases. An AI product manager should have a strong opinion about, hey, this model is the right model to use it for this use case, and for our customers, we probably should be using this model. we're going to talk more about these types of models and how they map to the use cases that really matter and drive impact to customers. So if this is interesting to you, if you have a different definition of machine learning, subscribe to the channel, drop a comment below, and let's go drive some business innovation. Let's go disrupt some customer experiences with AI. Join our community, join our channel. Thank you very much.